Welcome back. In this video, we're going to talk about compositions of transformations. That's really just combinations of transformations. In other words, do a rotation and a reflection, or a rotation and a translation. Basically, we went over 3 different types of transformations. And so the quote-unquote 4th type would be like a glide reflection. That's just really another vocabulary word. That's where something's translated and reflected. So as you can see with these footprints, you can kind of argue that each footprint to the right is translating, and then you could reflect it to make your left foot's footprint. And so that would be a glide reflection. But I guess if you're like rotating and reflecting, that's not a glide reflection. I don't know what that would be called. There's not like a vocabulary word for it that I'm aware of, but if you find one out, let me know. With that being said, let's just get started doing the examples. Okay, with this first example, I'm going to translate along the vector 0, 4, which just means 0 is the first number, so that means I'm not going to change the x coordinates, and 4 is the second number, that means I'm going to add 4 to all the y coordinates, and then I'm going to reflect those points across the y-axis. So I'm going to do j prime, and k prime, and l prime, and all those x coordinates are going to stay the same, so 6, 10, and 5, and then all the y coordinates are going to get 4 added to them, so that's going to be 3, 2, and 1. Alright, so now I have to reflect them across the y-axis. So from the other videos, a y-axis reflection just means you're going to flip the sign on the x coordinate. So j double prime is going to be at negative 6, 3. And k double prime is at negative 10, 2. And L double prime, I really need to get a new stylus. I cannot write with this one. Negative 5, 1. But until that happens, you all must suffer. Ha ha ha. So yeah, that's a 10, not a negative 1.0. Okay, so I'm going to graph these points to the right. It should look like the first one goes 4 units up, and then the second one flips across the y-axis. Okay, so I went ahead and I graphed those over here, and you can see the translating up 4 units, and you can see the red triangle is now reflected across the y-axis. So each transformation feeds into the next one, and that's how the other ones are going to go. Okay? So maybe if you're watching this, try the other ones and just see if they match mine too. So the first transformation is going to be a translation along 5, 0. That means add 5 to all the x coordinates. So b prime's 2, the y coordinate stays the same. G prime, add 5, so that's 4, comma 3. T prime, add 5, that's going to be 4 again. Hey, that 4 one looked okay. 1, and then S prime, 1, 2. And then I'm going to reflect those across the x-axis. So let me scroll down a little bit. Okay. Reflect those across the x-axis. So B prime. X-axis reflection means it's flipping top to bottom. So the y sign, excuse me, the y sign will change. So 2, 4, 2, negative 4. 4, 3, G double prime, double prime, for negative 3. T prime for 1 goes to 4, negative 1. And S double prime 1, 2 goes to 1, negative 2. Okay, and now I just need to graph those to the right. Okay, so here are the graphs. The blue one I did in black. I should have been consistent. Oh well. Everything shifted right 5, and then everything reflects across the x-axis, so it folds down. And they should all look the same shape, which they do. If only I could graph better. But yeah, let's do a couple more examples and call it a day. Alright, so the example 3, the endpoints of CD are negative 7, 1 and negative 3, 2. Graph it, CD and its image after a reflection in the x-axis and a rotation of 90 degrees about the origin. Okay, so C prime, reflection of the x-axis. That means change the y-coordinate. If it's positive, change it to negative. If it's negative, change it to positive. So negative 7, 1, negative 1. And D prime will be at negative 3, negative 2. And so C double prime, rotating that 90 degrees, will be, that's a negative yx. That's what you do with the coordinates, I should say. So negative yx would be, looking at C prime, negative y would be positive 1, x negative 7. D double prime, looking at D prime, negative y would be positive 2, x would be negative 3. Let's graph those to the right. Okay, and so in red, I have it reflecting across the x-axis, so it flips downward, and then I'm going to rotate that one 90 degrees, so that's going to be a quarter turn to the right, to the left, and that's it for example 3. Let's do example 4 and call it a day. Triangle TUV has vertices right there. Graph TUV and its image after a translation of negative 1, 5. So that means subtract 1 from all the x coordinates and add 5 to all the y coordinates. So T prime, subtract 1. 2 minus 1 is 1. Negative 1 plus 5 is 4. And then U prime, 5 minus 1 is 4. Oops, I wrote U prime and I put a comma. 4, and then negative 2 plus 5 is 3. And then V prime, 3 minus 1 is 2. Negative 4 plus 5 is 1. Alright, now rotate those 180 degrees about the origin. 180 degree rotation states reverse both of your signs, but keep the same order. Alright, so negative 1, negative 4, U double prime, negative 4, negative 3, and then V double prime, negative 2, negative 1. I really do apologize about my sloppy handwriting. I am trying my best here. I just can't write very well on the tablets. So yeah, this is a 4. Okay, so we'll just graph it to the right and look at it, and then we'll be done. Okay, so when I was graphing it, I had this triangle printed on there that had really nothing to do with the original, so I just kind of scratched it out. So here's the original down there in black, and then that's being reflected across, not reflected. Everything went one to the right, one to the left, and 5 up. And then that went reflected to the rotated 180 degrees, which kind of looks like it moves diagonally. Yeah, so if you're working on this alone and you're checking your work, hopefully yours looks like mine, only a lot neater. Alright, thanks everybody, and stay tuned for more videos. Bye-bye.